Hello, I'm Elijah Lowe, and today I'll be discussing the physics behind the hit movie, the SpongeBob SquarePants movie. Although SpongeBob doesn't often comply with the laws of physics, this scene specifically violates those principles. Roll the clip. Let's stop the clip right here. This appears to be a young David Hasselhoff carrying SpongeBob and Patrick on his back while he swims. Normal, right? Wrong.
Next stop, Bikini Bottom! I got you, SpongeBob!
Thanks, buddy. Thanks a lot.
That's it! I'm through messing around! See you later, fools! See ya!
Okay, fellas, this is where you get off. Bikini Bottom's directly below.
Before we start, I just want to notify that the person that made the template for this presentation was not officially licensed by SpongeBob to use their characters, and that's why we have this jolly little guy instead. Let's break this down. David Hasselhoff is going to carry SpongeBob and Patrick all the way from Shell City to Bikini Bottom. Well, it seems that he's going at a kind of accelerated rate. Let's see exactly how fast David Hasselhoff is moving. So at the start of the clip, SpongeBob is located in Shell City. Let's see when they start moving. So they start moving around 1 minute and 20 seconds. Let's continue on and see where they finish. I messed up the point where we stopped the video, but they finished around 4 minutes and 18 seconds. So in total, they took around 168 seconds to make it to Bikini Bottom. So I've written down the time here, and we can see that it takes around 3,000 miles to get from Shell City to Bikini Bottom. So I looked up that 1 mile is approximately 1,609.344 meters. Using quick dimensional analysis, I can get the calculation that 3,000 miles is about 4,828,032 meters. Those are our key values, a time of 168 seconds and a distance of 4,828,032 meters. Now let's put down our kinematics equation. Delta x is equal to at squared over 2 plus v naught t. Let's assume that it has no acceleration. We'll get that delta x is equal to v naught t. After plugging in our values, we see that v is approximately 28,738.28571 meters per second. We can see here that the fastest ever speed reached by a human swimming is 2.29 meters per second. Because of this, we can assume that this is just not possible. Okay, now that we discussed that, I'd like to discuss another part of the scene that also just doesn't make sense. I'll play it right here. Throughout the clip, it looks like he's going at a constant velocity, so I'll write that down right here. Earlier, we stated that he was going at 28,738.28571 meters per second, but on this chart that I'm showing right here, an average boat travels much slower than that. He was only going a little bit faster than the average boat, and that boat wasn't even going at its top speed. So, let's get into the good physics of how this would work. Let's take our equation from earlier. Delta x is equal to at squared over 2 plus v naught t. As I said earlier, we're going to say that acceleration is equal to 0, so we can cancel that out right here. Now we have delta x is equal to v naught t. Let's take a look at our original distance, 4,828,032 meters. Now, let's set that equal to the velocity, 30.87 meters per second of a boat, and we'll multiply that by time. After we do that, we can divide our distance over our rate and we can get that it would take around 156,398.83 seconds. That's about 1.810 days. SpongeBob would definitely not be able to make it in time to save Mr. Krabs. Let's move into our next topic, energy.
Flippin' physics.
So, class, how do you think he's propelling himself in this clip right here? Tony, you have an answer?
I think he's farting.
Propelling. I don't think so.
Oh, pick on me! He's a cyborg.
Unfortunately, this isn't right.
Oh, I know, Mr. Lowe. He's definitely breaking the law of conservation of energy.
You're correct, Sid. Let's explain what the law of conservation of energy is. The law of conservation of energy states that energy can neither be created nor destroyed, only converted. So we'll write down that E initial equals E final in this scenario. Now, we're only really focusing on mechanical energy, which is a combination of both kinetic energy and potential energy. So we'll write down that K1 plus U1 is equal to K2 plus U2. And in the clip, we see that he starts out by swimming, but it is such a minuscule speed in comparison to what he's supposed to be going to that we can just cancel that out and say it's 0. Now we look at his potential energy, and we can also assume that's 0. Let's go to the other side. The kinetic energy we'll solve for soon, but the potential energy, he still has 0. So we can see that K2 should equal 0, but let's solve for what it actually is. Kinetic energy is equal to mv squared over 2. In this case, K2 is equal to 87, which is David Hasselhoff's actual mass in kilograms, times 28,738.286 meters per second. And we're going to square that. And we're going to put all of that over 2. We'll find that K2 is equal to 3.593 times 10 to the 10th power joules. Let's check back over on the left side. 0 is equal to 3.593 times 10 to the 10th power joules. That is not equal. Because of this, we can say that this is not possible. Now, let's get into the good physics part of this video.
This is what zero kinetic energy turning into zero kinetic energy looks like.